3.9 seconds to 100 kilometers per hour, dual motor all-wheel drive, 630 kilometers of claimed range, and a sticker price that undercuts a base BMW iX1 by roughly 30%. On paper, the 2027 BYD Atto 3 reads like a spreadsheet error, but the real question isn't whether BYD can hit those numbers, it's whether they've finally solved the thermal degradation, suspension compliance, and software latency issues that kept the current generation off serious enthusiasts' radars. Today, we're breaking down leaked engineering documents, supplier manifests, and prototype test footage to see if this is actually a driver's EV or just another spec sheet warrior dressed in crossover sheet metal. BYD isn't just refreshing the exterior panels here. They're rolling the Atto 3 onto an evolved version of their e-Platform 3.0, and the structural changes are where things get interesting. The current Atto 3 uses a traditional body-on-battery layout with bolted crossmembers and isolated pack mounting. The 2027 model reportedly shifts to a cell-to-body architecture, where the blade battery casing becomes a fully stressed member of the chassis. Supplier documentation out of Changsha points to a 22% increase in torsional rigidity, which matters because the outgoing car flexed noticeably under hard cornering loads and uneven pavement. If BYD's chassis engineers have properly tuned the hard points and bushing durometers, that stiffness translates directly to sharper turn-in, less suspension deflection, and more consistent alignment under load. They've also moved to larger single-piece rear megacastings, which cuts weld points and shaves roughly 18 kilograms from the white body. That's not showroom marketing, that's fundamental weight reduction and structural optimization. Let's talk about the pack, because this is where BYD actually holds a measurable advantage over most European rivals. The 2027 Atto 3 is expected to use a second-generation blade cell with a revised cathode doping process and tighter cell stacking tolerances. BYD hasn't published the exact chemical ratios, but independent teardowns of recent LFP modules suggest they've pushed volumetric energy density up by roughly 12% while keeping the lithium iron phosphate chemistry intact. That means you still get the thermal runaway resistance and cycle life LFP is known for, but with less mass penalty. The claimed 630-kilometer range is almost certainly WLTP, so expect somewhere in the 480 to 510 range in real-world mixed driving at highway speeds. More importantly, the thermal management system has been completely reworked. The outgoing car used a single-loop coolant setup that struggled during repeated DC fast charges or hard backroad use. Prototype testing footage shows a dual-circuit system with a dedicated chiller for the inverter and a larger heat pump that pulls waste heat from both drive units. The cooling plates now run serpentine channels directly under the cell modules instead of relying on side-mounted heat exchangers. If the charging curve holds, you're looking at a 10 to 80% charge in about 22 minutes on a 350 kilowatt cabinet, and with significantly less power tapering after 50%. That's the kind of thermal stability that separates daily commuters from cars you can actually road trip or run through consecutive hot laps without babysitting battery temperature. Now for the numbers that got everyone's attention. The dual-motor all-wheel drive variant is targeting 3.9 seconds to 100 kilometers per hour. That puts it squarely in BMW iX1 xDrive 30 territory, but the way it delivers that power is completely different. BYD is switching to silicon carbide inverters for the front and rear drive units, which cuts switching losses, improves high RPM efficiency, and reduces inverter heat soak. The motors themselves use hairpin windings with a higher slot fill ratio, which improves torque density and reduces copper losses under sustained load. The rear motor handles the bulk of the torque under normal driving, while the front unit engages via an electronically controlled multi-plate clutch when slip is detected or when you map the throttle. There's no mechanical center differential, so torque distribution is entirely software-driven. Leaked calibration files suggest BYD is running a rear-biased split under hard acceleration, roughly 35 front to 65 rear, which should help it rotate better than the current front-heavy setup. The question is whether the traction control algorithms can manage that instant torque without cutting power aggressively. Early prototype drivers in Guangdong reported a much smoother torque ramp-up compared to the 2024 model, but we'll need actual V-box data and dyno pulls before calling it a properly calibrated driver's car. Still, matching the iX1's straight-line numbers and leaving room in the budget for better suspension components is a serious engineering flex. Acceleration means nothing if the chassis can't handle it, and this is where the outgoing Atto 3 has always drawn criticism from track day regulars and alignment shops. The 2027 model keeps a McPherson strut up front and a multi-link arrangement out back, but the geometry has been revised. The lower control arms are now forged aluminum instead of stamped steel, and the rear toe links have been lengthened to reduce bump steer under compression. BYD's chassis team has reportedly stiffened the front anti-roll bar by 15% while softening the rear slightly to encourage rotation and reduce understeer on liftoff. Steering ratio drops from 15.6 to 13.8, which should make it feel more responsive on initial turn-in without requiring constant mid-corner corrections. Brakes are still single-piston floating calipers up front, but the rotors have been upsized to 340 mm with directional internal cooling vanes and higher carbon content for better fade resistance. It's not a dedicated track setup, and it doesn't pretend to be, but for fast back-road driving, occasional track days, or just confident highway merging, the geometry changes should finally give it the compliance and feedback that enthusiasts have been asking for. Weight distribution sits around 52 front, 48 rear, which is about as balanced as you'll get in a transverse EV layout without moving the pack further behind the axle line. Outgoing alignment specs show a slight negative camber up front and neutral toe, which means you won't need to immediately book an alignment shop visit just to make it handle properly. Inside, BYD has clearly been listening to the criticism about software lag, switchgear quality, and driver positioning. The rotating screen remains, but it's now running a custom automotive-grade chipset with significantly lower input latency and a dedicated CAN gateway that isolates infotainment processes from critical vehicle controls. Physical buttons have returned for climate control, drive mode selection, and traction control toggles, which is a welcome change for anyone who's tried to adjust fan speed or disable stability nannies while wearing driving gloves. The driver's seat has been redesigned with deeper side bolsters, a lower hip point, and a longer cushion, fixing the perched driving position that plagued the outgoing car. Wiring harnesses are now routed through sealed channels under the floor pan, reducing cabin NVHR and improving long-term durability against moisture and road salt. Build quality on pre-production units shows consistent 3mm panel gaps, proper sound deadening in the wheel arches, and serviceable fuse boxes that don't require dashboard removal to access. It's not hand-stitched Italian leather, but it's honest, functional, and built to withstand actual use rather than just showroom lighting. DIY modifiers will appreciate that the 12-volt battery is now mounted in the front trunk with standard terminal access, and the underbody panels use quarter-turn fasteners instead of single-use plastic clips. The 2027 BYD Atto 3 isn't trying to be a luxury crossover, it's trying to be a properly engineered compact EV that doesn't compromise on chassis dynamics, thermal management, or serviceability just to hit an aggressive price point. If the leaked specs hold up during independent testing, and if BYD's software team can nail the torque vectoring calibration without over-relying on brake-based intervention, this could genuinely pressure the iX1, the Volvo XC30, and even the base Model Y. But we've seen promising spec sheets before. The real test will come when we get it on a dyno, run proper charging curves with thermal imaging, push it through consecutive hot laps, and see how the suspension bushings hold up after 10,000 kilometers of real-world abuse. What's your take? Is BYD's engineering trajectory finally catching up to the established European brands? Or are we still looking at a spec sheet promise that'll fall apart when the data loggers start running? Drop your thoughts in the comments, and if you want proper instrumented testing instead of brochure reads, hit subscribe. We'll be on the ground when the production units land, and we'll show you exactly what the numbers say.